exercise 6H. We're looking at families of cubic polynomial functions. Perfect. So basically it starts off by saying, hey, in the first few chapters we've been looking at different things like straight lines and then quadratics, and we've also looked at hyperbola and things like that. Now it's given some examples of some common cubic polynomial functions. So again, you can kind of have your standard sort of cubic function, y equals ax cubed. Obviously a is going to have a value, or they're saying here if a's got a value of greater than 0, then it says the cubic graph has a dilation from the x-axis of y equals x cubed. Yep. So obviously it stretches out there along the x-axis depending on the value of a. They've said a greater than 0 because obviously when a is a negative value it flips things around and makes the cubic go the other way. Obviously again you can have sort of the translation sort of format of a cubic. Operates very similarly to quadratics. Again, k value determines how far up or down graph is translated. This h value that's here determines how far left or right it is translated. So you can have that type of format again, which is useful if you know it's about translations. This one here, where you've got it's sort of factorized with an a value at the front. Again, when you've got this here, you can solve each of these parts of the cubic, and you know that this is where they're going to cross over the x-axis. Yep. So this is where the x-intercepts are going to occur by solving each of these values of x. So here, obviously, solving this and making it equal to 0, x is equal to 2. Here's x is equal to 5, negative 5, sorry, and x is equal to positive 4 here. Yep. So that's where it's going to cut the x-axis. Which is useful to know. Last one you can have here is expanded sort of format, ax cubed plus bx squared plus cx. And in this particular case, you're going to have a cubic that passes through the origin at 0, 0. Now, what they can ask you is to find the rules of the cubic polynomial functions. It says here the method used for finding the equation from the graph of a cubic will depend on what information is given. So you have to read the question and actually go, okay, they're giving us some turning point information. Aha, I need to use the turning point sort of notation for the cubic. Or they might give you some x-intercepts of a quadratic. You go, okay, well, I've got the x-intercepts, I'm going to use this particular format when solving it. Yep. It says here, for those that are not in this form, the information given may be some or all of the x-intercepts as well as the coordinates of other points, including possibly the y-axis intercept. Cool. So they're saying they're going to give you some information. You need to make a decision here as to which one you're going to use. Let's have a look at this in action. This is example number 29. It's on page number 243 for those of you who are following along at home. It says a cubic function has the form y equals this here. They're also telling us that this particular point, 310, so x and y coordinates 310 is also on the graph. So we've been given a fair bit of information. Cool, it says find the value of a. Perfect. Here's how you go about solving this one. Write out the question. Check. Everyone should be happy doing that. What we're going to do is we're going to substitute in the value, the additional point that we do know. So this is the x value and this is the y value at that point. We're going to sub in x and y values into the equation. So where y is, we're going to substitute in the 10. Where x is, we're going to substitute in the 3, which is what they've done. We're going to simplify things down and rearrange and solve. You should be fairly happy moving things around. Obviously 3 take away 2 is 1, it's just 1 cubed. Take away 2 from both sides, this gives you the 8. Rearranging again, dividing both sides by 1, get a equals 8. Cool. You could then rewrite out, actually they were just asking you to find out the value of a. So the value of a is 8. You don't need to write out the whole question again. This one here, it says a cubic function has the rule in this particular format. Good, so they're giving us some x-intercepts here. And they're also telling us that the point 5, 16 is on the graph of the function. Again, finding the value of a. The same thing applies. We've been given the coordinates 5, 16. We're going to plug those into the equation where x and y are, which we've done. We're going to simplify things down and evaluate, and then rearrange, and we get a equals 4/7. I think most people should be fairly happy doing that. Turning over the page, we're looking here at worked example number 30. It says here a cubic function has the rule. Here we've got ax cubed plus bx, and they've given us 2 points this particular time. They've got 1 and 16, so x and y values, and another set of x and y coordinates, 2 and 30. Perfect. So from here, you can actually evaluate or create 2 equations. So it's basically saying when you substitute 1 into the function, so f of 1, it's going to come out to being 16, which is what we've got. And when 2 is substituted in the equation, so f of 2, it's going to evaluate to 30. Yep. So that's good news there. We're going to use this information to create the simultaneous equations. So here, what they've done is they've written out this one here, ax cubed plus bx. They've substituted in, first of all, x is 1 and y is 16. So you can see y is 16 here. A multiplied by 1 cubed is just, we know 1 cubed is 1. 1 lot of a is just a. Same difference here when you substitute in 1 here. B times 1 is just b. 1 lot of b. So that's how that simplifies down there. So we've got one of the equations, we've labelled that. Doing the same thing except substituting in 2 and 30. So you can see they've written it out. Where y is, they've substituted in 30. Where x is, they've substituted in 2. So simplifying things down here as well. Obviously you're going to have 2 to the power of 3. And that's going to obviously go in front there. Once you have simplified things down, it's a matter of using solving simultaneous equations. Again, there's different ways you could go about it. You could use elimination, or you could use substitution, or you could use your CAS calculator if you have that available to you. In this case, what they've done, they've multiplied this one by 2, and then they've subtracted them away from each other. By multiplying this one by 2, obviously you'll end up with 2b here, subtracting them from each other, and you'll end up eliminating these b values. So you end up with negative 2 equals 6a. You can work out from there what a is. Happy days, you've got a. As we've always said, once you've got one of these variables, you can substitute that back into one of the original equations. It doesn't matter whether it's this equation or this one. My recommendation generally is to substitute it back into the easier calculation. I'm going to put it to you, it's a bit easier to substitute into this equation. Rearrange and you can find out what the b value is. In this case, it is 49/3. Cool. Worked example number 31. It says here, determine the rule for the cubic function shown in each of the following graphs. Alrighty, so this one's working a bit differently. We need to consider the information that we're being given. So with graph A here, we know that it's cutting, or these are the intercepts, yeah? So it's got an x-intercept at -1. So consider when you've got a cubic, one of the factors is going to be x plus 1. Yep. So you know this bit is going to be where it cuts the axis, because it tells us. When you have a factor that is squared, whoops, what am I doing here? We don't write out, okay, we've got a factor x take away 2, x take away 2. Well, you could do that, but you don't write them out twice. Yep. Generally, as mathematicians, we just say, okay, we've got x take away 2 squared. Yep. When you have a squared factor, it means it's not going to cut the x-axis at that particular point. So it's not cutting at 2, a positive 2. What it's going to do when it's a squared factor is it's going to just touch the x-axis at that particular point. So here at positive 2, you'll notice it's just going to touch the x-axis. It's not cutting at that particular point. Yep. So we've set up the format here. We're using, if we refer back to the first page of this exercise, it's the third style of equation where it's you've got the x-intercepts. So it's going to be in this notation, y equals a and then the factors. Also, we know that there is a point on the graph that we can use. So we've got a point labelled as 3, 2, an x and y value. You can substitute those into the equation where x and y is and rearrange things to work out what the a value is. Perfect. We've worked out that a is a half. Once you have the a value, you can write out the rule in full here. So the rule for this equation is 1/2 is the a value x plus 1, which is where it cuts at -1, and also it's touching at x plus 2 because this is a squared factor here. Yeah, cool. Perfect. Yeah, I'm saying the squared. They say it's a repeated factor. It's the same thing there. Yeah. Alrighty, next one. We've got an equation. Oh, cool. Perfect. In this particular case, it is your sort of standard cubic graph, but it has been translated. The point of inflection has moved. Obviously, normally it's at 0, 0. It's moved to the left by 1. And it's also moved up by 2. Yep. So in this particular case, you know the k and the h values. Yep, the way they are translated. So you can write that out. I would have, yep, y equals ax plus 1 cubed plus 2. Yep, because it's moved up 2. They've, rather than having it as obviously x plus 1 cubed plus 2, which shows the translations left and right, they've moved this plus 2 over to this side. I'm not sure why they've done that at this particular point. From here, once you have that, you do have some additional information. You are also given a point, 1, -2, so an x and y value, which you can substitute into this equation, whether it's this one or whether it's the y equals this plus 2. You should still get the same thing when you rearrange it. You should get that a is equal to -1/2. Yeah. With this question here, they've written it out as y take away 2 equals -1/2 x plus 1 cubed. I'd probably prefer it just y equals -1/2 x plus 1 cubed plus 2 as the answer. Yep. So it's just y equals. Not sure why they've done that like that. They've just felt like it. It's still correct. I'd prefer it the other way. Yep. All right, last thing to have a look at. Oh, cool. What's this here? It says a cubic function has the rule here. They've given us the rule. And they're also telling us when f of 1, so when you substitute 1 in as x, the equation comes out to being 0. When you substitute 2, it's -7, 4 is 27, 5 is 80. So these are the x and y coordinates that basically told you on the graph. So imagine some points that are already on there. Here is the rule for that. Essentially, the way to do this particular question is to use your CAS calculator. Yep. So on the ClassPad calculator, I would, in the main section of your calculator, you need to use the define. And here's where things went a little bit wrong with this particular calculator. Some people go and enter this into your calculator, define. Where you've put in these A, B, C, and D values, you have to use the variable letters, not the A, B, C letters. Okay, so just be careful of that. And also, sometimes people have had errors as well where things have already been stored in variables. So they've already said X is equal to something else in the past. When you do these questions, you have to go to edit and clear the calculator's variables, or go edit clear all. I always recommend doing that to avoid tears with these questions, because these cause grief. Yep, guarantee people are going to have problems. So here, my advice, clear all the variables. When you are entering these values, A, B, C, and D, use the variable button there. Next, so you'll define the function. It says here, highlight the expression and go to interactive define. Use the default name as f and the variable x, and that'll give you this here, and you'll be able to type that in. It says in Math 1, select simultaneous equations icon. So it's a little brace, a little squiggly bracket. So it's a brace with these two things. if you click on it, it'll only come up with 2 sort of things in the template. Because we've got 4 parts to it, you just click this a few more times, the button, and it will, each time you click it, it'll just add another field to the template. So you get 4 of them in there. Type in each of the equations. Here, f of 1 was equal to 0, and so forth, so forth. There's the 4 of them. After this little bar in the template, what you need to do is actually say, hey calculator, these are the variables that I want you to solve. I want you to tell me what A is, what B is, what C is, and what D is, and separate those with a comma. I feel that when I did it on my calculator here, I used just the normal letters, the normal A, B, C letters, not the variable letters. If calculator is coming up with errors and things like that, it's to do with which letters you use, whether you use the A, B, C, or whether you use the variable letters. I feel that in this picture, it's different. Yeah. After you've entered it in, you press enter, and it will happily calculate what the values or the solutions of A, B, C, and D are. Please actually have a go on this on your calculator to see which variation, whether these are the variable types or whether these are the A, B, C types or vice versa. I can't remember which one works and which one doesn't. I haven't got my calculator with me. You'll soon discover. If the calculator comes up and says no solutions and you've entered this in, something's not right there. I would try the other lettering in these different spots. I'd clear your calculator and so forth. Clear the variables. Yep. Please take the time to get this happening, because nothing worse than when you're trying to do things and you're under a bit of pressure in a happy fun assessment and your calculator's not working. It's because of these things. You wish you had known how to do it comfortably at a time that was more convenient.